Hello class, today we're going to be talking about proportional relationships and direct variation. Now it's going to be very important to pay attention to vocabulary today because we're going to introduce a lot of terms, but you're going to find that they actually mean the same thing. So keep in mind the things that you've learned about slope and we're going to dive right into it. Direct variation is defined as when y directly varies with x at a constant rate of change. These variables are in a proportional linear relationship. Now it might seem kind of funny that the definition of direct variation uses the words directly and varies, but let's think about what those words mean. Directly means it's very straightforward. It's exactly what you see it as. There aren't any other factors that you have to think about. It's really simple, direct. Now varies, we know, means change. So this is talking about when y changes with x at a constant rate. That means as x changes, y will change as well. And as x continues to change, y will continue to change in the same manner. So these variables are in a proportional linear relationship. Remember, proportional means that the ratio will always stay the same. Linear is when we talk about graphs, and that just means they change in a graph. It would be on a straight line. So when y and x are in a direct variation relationship, the graph must pass through the origin. Now you should remember that the origin is the point 0, 0. So when we are writing direct variation in an equation, we have y equals mx or y equals kx. So if you remember from our last video, we defined m as slope, which is also known in direct variation as the constant of variation. And the variable we use for this is k. Now, I told you a lot of things would mean the same thing. So we have slope, which is also known as the constant of variation, and it's also known as the unit rate. So remember, unit rate is when x is 1, and that's how much y will change by. So every time x changes by 1, y changes by a certain amount. And that's the unit rate. And this is also known as the constant rate of change. Now, why are there so many terms that mean the same thing? The reason is because we can find proportional relationships and direct variation from a lot of different mathematical representations. So we're going to be looking at graphs, tables, equations, and word problems, and we're all going to be using this equation, y equals mx or y equals kx. Remember, it's the same thing. So, how do we find direct variation? We said it's when y directly varies with x, and they have to be proportional, which means there's a ratio involved. So, remember when we talked about slope, we said that m was equal to rise over run. Now, rise on a graph is the y variable, and the run is the horizontal variable, which is x. So, when we're talking just about direct variation, the slope is equal to the constant of variation, m equals k, which is equal to y over x. That's all you have to do. You have to find out how much y changes for every time x changes. So, let's go ahead and look at these examples. Look at this table right here. It says rice is our x variable and water is our y variable. So as the amount of rice changes, y will directly change with x. So remember, we said k is equal to y over x. You can see right here, we have that point 0, 0. this passes through the origin, so we know, okay, this is direct variation. So let's pick any point and you do y over x. So let's look at this column right here. Y over x would be 2 over 1. Okay, and if we look at this one over here, we see y over x would be 4 over 2. And this one, y over x is 8 over 4. Now, all of these ratios, y over x, simplify down to 2. So k equals 2. If we are to write a direct variation equation from this, it would simply be, remember, we have y equals kx. Well, if k equals 2, then our equation is y equals 2x. Now, let's look at this graph. It's the graph of the same information that we just looked at in this chart. First thing you notice, it passes through the origin, right there, 0, 0. Now let's pick another point. Now make sure you're looking at the axes to see what the scale is on each of these. So we said k is equal to y over x. In this case, because we're looking at a graph, we know that we're actually looking at slope. So m, that's where these different vocabulary words come in. When we're looking at a graph, we're looking at m. M is equal to the rise over the run. So let's start from this lowest point. We're going to rise 2, and then we're going to run 1. So again, make sure you're looking at the scale. This might look like 2, but it's 1. So our rise is 2, and our run is 1. That's the same thing. M equals K equals 2. It's the same thing we got from the table. And no matter what point you picked, it would simplify down to the same thing. So if we picked 4, 8, then you would rise 8 and run 4, and you would end up with 2. So again, y equals 2x. So number 1, we have another graph, and it says ice cream cost. The cost is on the y-axis, and the number of scoops is on the x-axis. The first part says, using the graph, determine and interpret the slope. So slope, m equals rise over run, which is equal to y over x in this direct variation equation. So right here we pass through the origin, and I'm going to pick a random point. We have the rise, let's say we rise 1, and then we run 2. So our y over x is 1 over 2. Now, how do we simplify this in a way that makes sense? You notice on this side it says the cost, and it gives us these numbers in decimals. So while usually we want to keep the fractions, in this case, because of the problem that we're looking at, we're going to write this in a decimal form, 0.5. Now, what does this slope mean? If you look, no matter what point you choose on the graph, this is going to stay the same. So let's say we're looking at this point right here. You rise 1.5, and then you run 3. We simplify down to the same thing. 1.5 divided by 3 is also a half, 0.5. So what exactly does that mean? If we look at our simplified fraction, we got 1/2. For 2 scoops of ice cream, which is x, it's going to cost $1, which is y. If we simplify that down, we get 0.5, which means that every scoop of ice cream costs 50 cents. Okay, so every time we find a slope, it's going to have some meaning, and you're going to have to look at the axes to be able to know what the meaning is. Now it says write a direct variation equation. Well, y equals mx, so we know that y equals 0.5x. So each of these problems is going to have various parts that you have to answer, and you need to make sure you're checking what they're asking you for. Let's look at example 2. It says, determine the constant of variation and interpret its meaning. So we know that this is a direct variation table. We have the number of beats as our x variable and the blood pumped in gallons as our y. So the constant variation K equals y over x. So we can pick any point. Let's look at this first one. 180 over 3. And because it's constant, no matter what we pick, it'll all simplify down to the same thing. So 180 divided by 3 is equal to 60. 360 divided by 6 is also equal to 60. So K equals 60. Now what does that mean? Again, look at what these variables say. The number of beats and the blood pumped in gallons are Y. So Y up here is the amount of blood and X is the number of beats. So when it's simplified down, we know, even though we don't have to write it out, we know that it's 60 over 1. Remember, this is the same thing as unit rate. So Y is the blood pumped in gallons, and 1 is the number of beats it takes. So we can interpret this as, for every beat, which is X, for every beat, 60 gallons of blood are pumped. So for every 1 beat, there's 60 gallons of blood pumped. For 3 beats, 180 gallons. For 6 beats, 360 gallons, so on and so forth. We write a direct variation equation. Y equals Kx. Y equals 60x. So this really is very simple. All you're doing, you're looking at Y, you're placing it over X, you're finding the ratio of that, and that's going to give you your M or your K. Then you just interpret it. Let's look at this word problem. It says Barney earns $24.75 in 3 hours. If the amount Barney earns varies directly with the number of hours, write a direct variation equation. So just thinking about this, we're talking about work. What do you have to do first in order to earn money? It depends on the number of hours. So the thing that varies directly is Y, and the number of hours is X. So X changes first, and then Y will change. So the amount of money is Y, the number of hours is X. Write a direct variation equation. So we are looking for Y equals Kx, but we have to find K. So K, remember, equals Y over X. And here we're given $24.75 for 3 hours. Now divide, and you will find that you get $8.25. So that is our K. For every hour Barney works, he gets $8.25. So Y equals 8.25x. Okay, now it's going to ask us to extend what we know. It says, how much money will Barney earn in 7 hours? Because we have this equation, remember the hours is X. That's what changes first. We can just plug it into our equation. Right? So Y equals 8.25 times 7. If you use your calculator, you're going to get $57.75, which is your answer. Now, you have a few practice problems to apply everything we've learned. Complete these problems before you come to math workshop.